Okay, welcome to week 2. It's flying already. I can't believe how fast it is. I guess what's important for you this week is that your labs start today. So there's a lab after this. The ASH group are in starting after this one, I think, is it? Yeah, yeah. And then there's a tutorial later, and then there's another lab later in the day. Some people did contact me about being able to move between the various labs. I think I've accommodated everybody, that. But if you still have issues with labs and times, and things will have changed over the past week, do let me know. Please, that would be really important, and we can keep everything up to date, and you'll be able to sign in. It's important that we know so that you can sign in. We have a record that you're there. Okay. So, but if you have problems, do let us know. And I guess what's important to realize is that life gets in the way of college a lot, and you may be in a situation where you can't get to a lab, you're unwell or something, and then in the morning, or you can't make it, and you want to get to the one in the afternoon instead. There's always wiggle room, so you can turn up and go to the lab. Just don't miss a lab, okay, if you can at all. It's important that you get them in. And the same, if you have something on in the afternoon, that you can't, that's unavoidable, go to the lab and say to Benham, I'm normally in the afternoon one. Can I come here instead, just for this one off? And that's usually no problem as well. Okay, so the labs groups tend to be progressing at the same rate, so that's not an issue. Um, it's important that you attend the tutorials. They start today as well. The tutorial is in this building in SLT. I tend not to give some of the information because at the time when I made all the documentation, I didn't give the detail of the room because I didn't know where it was at that point, but it's been updated and it's on the university timetable. And there's a link to that timetable from the welcome section in the Moodle page. Okay, so you can have a look there. It's an SLT. It's literally just down the corridor from here and on the right hand side. Okay, Science Lecture Theatre. So go for your tutorial today. Now the tutorials aren't lectures. Really they're meant to be student driven. So if you go with some burning questions, I presume, we released the assignment last week. I'd like you to, I hope you've had a look at that and had some thoughts about it. I'll come back to it a little bit later anyway. I want to give you just a short demo of maybe how you might generate some tables with loops, because I want to introduce C# today. But if you have questions and you don't understand something, the tutorial is the place to give it, okay? Chances are, if you are asking, you don't know something, you want to ask a question, somebody else probably has the same question. Okay, you may be very unique, of course, and have questions that are very specific to you, and that happens too. But generally, I may, when I give a talk or a lecture, I may have a way of expressing something that I think is absolutely clear as day, and then no one in the class gets it. Okay, so I got it completely wrong, for example. So it's good that you ask those questions in the tutorials, and the feedback ultimately comes back to me, and then I can change things and try to do better next time. Okay, so because every year is different, every class is different, my mood will be different, my understanding will be different, so nothing will be the same. There's nothing wrong with not knowing something. What's wrong, the problem is that when you don't know something and you don't know something and you're not prepared to ask when you have an opportunity, then this perpetuates. Okay, and then you're here to learn. As I said before, if you're not making mistakes, you're probably not learning. So always think about asking questions. And I've been in the classroom myself. I was a student for many, many years, and the worst feeling in the world is putting your hand up and saying, can I ask a question? Because there's two reasons for this. One is that you don't want to stand out as the person who doesn't know something, and then it might be a bit of embarrassment there. The other thing is that you might ask a question and suddenly other people think, God, I don't know what that is, that person's more advanced than me or something, and then people might feel not happy with somebody asking questions. Lots of reasons as to why people don't ask, but please ask questions. You must have questions. So as you're working, what I'd recommend is that you keep a little diary, and every time you come across something you don't understand, write it into that diary. Okay? I use the notes on my phone. When I don't come across something, I just tap it in there, go to tutorial, work with colleagues. For my case, I talk to colleagues or I talk to Benham, and we answer questions. I have my list of questions and I ask those questions. Okay, so you could ask those. So it's not like you have to think of something on the spot. So please do that as you work along. If you're in the labs, you come across something, write it down. Sometimes the act of writing it down helps as well. So please think about your questions. Keep them. They're really important for you and for us. Okay. You can always email Benham in advance of the tutorial. you know, and say, look, I'd appreciate it if you maybe could talk about this week for a few minutes. You know, that's okay too. You can do that. You can always mail me the questions too, or come to me with the questions. Um, that's fine. We tend to have Benham doing the tutorials rather than me, so that you get a different perspective. I don't do the tutorials generally, but I'm still happy to answer the questions. But I keep an eye on what's happening. Sometimes I might turn up just to listen to what's going on. Okay. Okay. So don't be afraid to ask. You get one shot at learning this, so use it. And it's a good opportunity to do that. And it's the same in labs. If you don't understand something, ask in the lab. They won't give you the answer to the problem. Your third year students, right? The other thing you have to remember is that you've progressed to third year. You're senior students in your degree. You're not too far off completing. Okay, we have expectations of you. We expect a level of maturity that we don't expect from first years. We spoon feed first years. We say to you, here's a piece of wood, carve your own spoon, and then make it. Okay, that's the mental attitude, and I have an attitude that you're mature coders at this stage. Okay? And I expect you to bring that to the labs and to the table, okay? And your understanding. This is about respect for how far you've come. It's a big deal being in third year. You go on a placement, many of you, in 6 months' time. So we have this level of expectation of your maturity. So use the labs, use them, really use them. You're not going to get an answer or get everything done in a lab, okay? They're there to help you address issues you might have so that you can progress with this. Okay, over a period of time. Yeah. This is about learning about yourself. I said that last time. Understand what kind of coder you are, where you find problems. And Google is your friend as well. I mean, I decided this. I was looking at my notes from last year, and I looked at them yesterday, and I watched a video of myself, and it just annoyed me. And then I looked at the notes again, and then this morning I thought about the assignment, and then I just did another example for you this morning. But I'm rusty, so I ended up having to go to Google. You look at my search history for the last hour, you see, oh, how do I do the basics of padding or with C#? I'd forgotten, and you will forget stuff, but practice will help. Okay, so everybody's the exact same, right? And so there's no problem with that. So we're going to progress into, and it's great to see so many people coming to class. Okay, I hope I don't scare you off or bore you too much over the year. Like if we still have this number in 6 weeks' time, I'll be delighted. But one thing you will notice is that I tend to have an approach to teaching, really, which is I start off, this is time, this is the level, I tend to go like this, okay? Okay. So in a short period of time, we have a lot of material, okay? I tend to do this, okay? Some people go like this, First year's a bit like this, but as we move in year, we tend to move a little bit. So first year, second year, third year, fourth year, whatever, okay? So we do more in the time. In other words, we ramp up really, really quickly, okay? That's how I do with this. If I was given this class to the master students, all of the material I would do with you today would be done probably about 20 minutes, okay, and gone. If you were first years, I'd spread it over 2 weeks or 3 weeks, okay? So if you wonder about the pacing, it's because I'm pitching it out. And that's why I pre-record half the lectures material so that you do have some time to be able to do it at your own pace, okay? Yeah. Because it is important that, your pace will be different to my pace. Your pace of learning will be different than my pace of delivery, okay? So that's why it's done that way. But in these classes, you can stop me at any point. So we're going to do the fundamentals of C# today. Really basic stuff, really, in terms of the language itself. It may not be basic for you in terms of, because it's new, and some people don't like new things, all right? They just don't like new stuff. Or it takes a while to get over the fact that it's new. You are as experienced programmers, like I said earlier, so you have experience of lots of different languages at this stage. So this C# is very Java-like. So all the stuff that you love and hate about Java will be there, okay? I'm going to do the object-oriented stuff next week, okay? But we'll just come to a little bit of the end. But for now, we're just going to look at some of the basic stuff that you're going to need to be able to do to get stuff done, okay? Some of the JavaScript you will do, you should know. I'm going to skip over some things, and really what you need to do is, if I mention iteration, you say, well, I know how to iterate. There's for, there's whiles, there's untils, there's do until, there's all of that stuff, So you know the construct at a meta level. You just probably don't know how to do it with this particular language yet. You know about object-oriented stuff. We got to have classes. We use classes to create objects. Objects communicate with each other by message passing, getter, setter functions, all that stuff. You know all this, okay? So really what we're going to look at over the next 2 weeks is how to do all of that stuff with C#. How do we do file handling? It's a fundamental operation. How do we do string? How do we create data structures? How do we do linked lists? How do we do all that stuff that you would know already from your other languages, okay? So we move through this quickly, and I tried to look and give you an example in terms of whole programs rather than just bits of the element. I'm not going to put up a thing saying, here's a for loop, here's the instructions for a for loop. I'll give you an example of that for loop embedded in some piece of code that will do something else, right? So it's always good when you're learning something new to learn how to do something useful rather than just the in-between parts, okay? And I make this mistake all the time, So I like to cook. Like, that's kind of one of my things. I've been cooking for about 30-something odd, 40 years maybe. Around about 40 years I've been cooking. Some things I cook all the time, and I'm still trying to figure out how to perfect this cooking. But so my wife said to me there during the lockdown, I'd like to cook a few of those things myself, And so will you teach me how to cook? And I said, yeah, no problem. I'll tell you how to do this, because I went straight into teacher mode, And the first thing I did was I said, okay, let's look at how we make sauces. So the first thing you need to do is I'm going to teach you how to make a basic roux. Because if you can make a basic roux, then you can make everything. So it's really, really important. And a roux is just butter and flour and cooking and adding milk and all this kind of stuff, Or water, depends whether you're in Italy, it'll be a different kind of thing, or wine or whatever, so the liquid, right? But I spent so much time talking about all the basics that I forgot to actually make the sauce, the meal, right? And you can do that with coding as well. You can focus on all those elements and then not write whole programs. It would have been much better if I said, look, I'll show you how to make a chicken a la king or something like this, and we start off and do this. So I forgot the important stuff that I do when teaching you guys, tell you about whole programs, okay? So we do this in life. So that's my approach for the next while. So in order to hopefully give you that impression, I'm going to do the C# fundamentals. So what's core, and you can stop me at any point, just stick your hand up if you've got a question. There's no problem there. We'll stop. And I'll repeat the question, so anybody who's missed the class, you want to look back over it, I'll repeat it. We'll have it here. So when we think about C#, and remember, C# is this evolution of the C programming language. C programming language is around when I was a young man, and there's some, you can look at some of the original books on this stuff, and then it evolved into a C++ from Björn Stroustrup, and then again I was doing my PhD around about that time when that came back in I was in my mid-20s or early 20s at that point. At that point I was programming in Fortran and Pascal and some of these programs, and then later on that was around about the time that object-oriented stuff came about, okay? And we're still lots and lots of C++, lots of gaming, software, lots of games written in C++. So, apart from the low-level stuff, which is written in assembly language, of course. Java came a little bit after that. And then C# is more Java-like. It has a different approach to how you might do object-oriented stuff. Okay, and a lot of that has to deal with how we handle or design inheritance in the language. Java is a single inheritance model. Did you learn this when you did Java? So one class can inherit from a single class. Yeah, you know this. Yeah, so class A extends B or something. Yeah, doesn't extend two classes really, but you can implement an interface which kind of simulates multiple class inheritance. Yeah, structure. You know that's the way. Yeah. Okay. So C# is very similar. Okay, as well. All right. So you have this single inheritance approach. So one of the problems that I often notice that when students are, reading about learning a new language, and this applies across the board for everything, is that you don't have the language, or you forget the language, okay? Or you were never taught the language, okay? Or you ignored it. Sometimes we're the ones at fault because we don't teach you, the language to use so that you can actually read documentation, for example, So I try to stick with the actual formal language here. It's really important. So so you might say, for example, that You might talk about names of classes or and this kind of thing, but actually they're identifiers. Okay, and this is the point I'm trying to get here, is that when you're reading, try to read and understand how you describe a programming language. Okay, it's really important, because a lot of the time the formal descriptions or responses or explanations use all of this language. Okay, it's called a language register. Okay, and if you have difficulties with the language register, you have difficulty with the language. Okay, so that's part of it. So learn the register, and you'll be able to read the documentation. Okay, so identifiers, for example, are just the names, and we use these to identify class variables, functions, any other user-defined item in some C# application. Okay, so the basic rules of naming are: an identifier has to begin with a letter, could be followed by a sequence of letters, and the first character cannot be a digit. Identifiers can contain any embedded space or symbols, as we've got that list here. You can use underscores. An identifier should not be a C# keyword. Now you know this, you heard this in the very first day of your coding in Java, way back, right? Way back. And the reason I guess I'm telling you a little bit about this is that even though you know about identifiers, we know the syntactic rules for identifiers here, there are also semantic rules, or no, that's not true. There are also coding rules, if you like, stylistic rules. All right. And you should probably note that when you have a function, or when you have a class, or when you have a variable, any of these constructs that exist within your application, they will have a naming convention, okay, a stylistic convention. So do you use uppercases or lowercases or mid, so if you have a function and you create a function, how do you name it? Even though you know these are the rules, you could call it bananas. It doesn't matter what the function is, but you should really call it a name that's appropriate. How long should it be? How much information should you convey as part of this? What's the style? Do you use upper or lowercase? Where do you use the upper or lowercase? So look at the functions. Okay, when you look at a function or some item that's been declared in your application, look at how it's defined and use that style and copy that style. Okay, it's really important, that you think like a C# programmer. Okay? Don't write your C# to look like Java. Write it to look like C#. And this matters when you go to companies. Okay, you get a sense of how the styling conventions or the coding conventions are in place. So it's really important that you be part of that C# and embrace that C# coding community. Okay? So it's a bit about you. Okay, so that's why I'm telling you about this stuff. It's not so that you know about identifiers, it's so you know about how to create them in a way that makes it look like you understand C#. Is that okay? Yeah, it's important. Conventions are important. Okay, styling, it's about indentations. I always have my functions like this. I always have my brackets, for example, up here on the right. Top one always starts on this. You've seen this if you saw me doing my JavaScript, yeah? So I always do my JavaScript like this. But you'll notice that when I look at C#, I do something like this. Okay? Because that's the convention. This is how we look at it. It's how the style the formatters do and all that. So these kind of things do matter in many respects. So try to embrace the styles. There are different kinds of data types. So you had your intrinsic types in Java, and you had kind of JavaScript was typeless. Okay, everything could be whatever you want it to be at one point. But there are different types of value type variables, okay, and they're all defined using keywords. So you have ints and longs, which are integers, doubles and floats, which are signed floating point numbers, chars, bools, which have two states, true and false, and these are all identifiers as well. Okay, and all of the value type variables in C# have ranges and default values, and you can check them using the size of function. Okay, and it's actually important to notice when you're doing some computation, and computation accuracy matters. Okay, so when you have general purpose languages and you need to be able to do computation, mathematics in other words, a lot of the time where the decimal points really make a difference. So if you're doing something that works out GPS to work with phones, you may need many different places of decimal places in order to be able to uniquely identify something. If you choose the wrong variables, use them in the wrong way or incorrect way, then you don't get the levels of accuracy you need. Okay, and that would be really important. I think earlier I mentioned that we should have some demos, And I can show you a couple of these just to give a sense of how they work and just to show you a little bit about a C# program. So let's have a peek here at this program here, which should be demos. I think I may very well be in Zen mode. I'm not sure. No, I'm not in Zen mode. Okay, so that's fine. Let's look at the file. So you'll see all of these demos in week 2, and you'll be able to look at this. I'm looking at this one, demos here. Okay, and so that's fine. We'll just close this down. I've got a very simple program here. Or no, yeah, this one. Okay, it's fairly standard project. All I really want to do is show you a little bit about how we might use these functions here. We have the same kind of program as the last time. Our namespace was called demos. The class is program. I just dynamically created that using .NET create console -o demos, and that created it. We use console.writeLine to write something to the display. You can see that I can include the value of a variable in a list with WriteLine to be using these chain brackets here. Okay, so it's the first one I'm actually copying. So if I had another variable here, x, which doesn't exist, I could just refer to this as 1. That would give me the value of 1. But that's how I'm doing this. Okay, so it's fairly straightforward, but I'm actually calculating the size of something here and printing it. Okay. So really what's important here is that, did you use printf or sprintf when you were using your other language? So equivalent, you essentially use the equivalent of sprintf and printf. Okay, so it allows you to be able to embed variables in the strings, okay, using chain brackets. And that's going to be useful for you, and we'll see a little bit about that later as well in the demo. Notice how functions are written here. We talked about this already. So this is WriteLine. So if we have a function that's been created in C#, we tend to use multiple words to describe what that function does, and we capitalize the first letter and the letter of each part. So when you're generating your own functions, this is how you would do this as well. Okay, that's fine. We can look at strings, string types. Let me see if I did this. Okay. So if we look at strings, as I mentioned last time, are immutable. Okay, so we'll see a little bit about that, how that works in a little while. But sure, we can just run this. And we get the information. So if you're ever worried, or you're trying to figure out why I can't assign this value to this variable and so forth, or why they're not matching properly, just use this size of, and you'll be able to figure this out. Okay, so it's fairly straightforward in terms of the number of bytes that are done. So we also have reference types. So those were intrinsic types, and those are the core types that are built in. We also have the notion of a reference type. Okay, so when you talk about Java and some of your other languages, we talk about something being an object or something being a fundamental or basic type or something. So the correct term to use is reference types. Okay, so we also work with these. They don't contain the data stored in the variables, but they're a reference, which is a memory reference or a location reference to the variable itself. So objects and strings, and another one called dynamic, okay, are examples of reference types. Okay. Now, have you studied C already? Yeah. Did you do some C? No. C++? No. Yes. No. Okay. So there's this notion, if you come across the language, you'll say students have issues. Students of, not you as students, but students which are learners of C often have issues with pointer types. Okay. And so they're not variables in themselves, but they can contain a pointer to somewhere that contains the variable. Okay. Sometimes we swap things around. We can swap references around. So it's a way of dealing with memory. And if you think that something I told you earlier is that C, C++, and C would be very low. They're quite low-level languages, and we use them for a lot for game development, for example. And then, game development relies on everything being fast. It has to be fast. And you've got so much to do. And most speed relies on being able to manipulate memory, quickly, directly. And this is why we have these. So an object, for example, is a reference type, and that can be assigned some literal value of null, and it also can be referred to as system.object. And when we deal with objects, we also come across a term that you need to become familiar with called boxing and unboxing. And this is nothing to do with your YouTube videos, being really excited about that new phone you bought or whatever. Okay, this has got to do with understanding variables. Okay, and the boxing is all about converting a value type to some object type, and unboxing is they're converting an object type to a value type. Okay, that's what boxing and unboxing does. We'll see an example of it in a minute. Okay, as well. Right. It's important you get this. It's important you get the language. When you did Java, you did casting. Do you remember this casting? Yeah. So you cast from one type to another. You may have sometimes it's easy when you have a class A extends class B, right? Or class child extends parent. Sometimes you may want to cast the child to the parent, for example, class in order to be able to use it somewhere. Yeah. Remember that kind of thing? Yeah. So it's like almost like a downgrading or upgrading an object. Yeah. Anyway. In C#, we refer to this as boxing and unboxing. And then you have to think about, so this is fine. So in C#, strings are an intrinsic fundamental type, really. Here, a reference type. And they have equality operators, which are equal, double bars, and not equal, bang equal, as the symbols. They're defined to compare the values of string objects, not the references. That's more intuitive, right? Should be more intuitive. When we say, is this string equal to this string? They're actually designed to compare the value of the references, not the references themselves, because the two references will be different. Yeah? So if I have string A equals A, string B equals A, if I was to go, is A equal to B? Because these two strings the same, because they're actually reference type, we would say no. Because they're two different references. They're in memory, two different places. But the value that those references contain are the same. That makes sense? Yeah? No? Yes? No? It's like, I'm John here. I have this name. There'll be another John over there. They have that name. Are both Johns, have both people got the same name? Yes, they both call John. Yes? Okay. Are they the same? No, because that's a different person. This is a different person. Okay? Same thing with strings. Strings have a reference. They're different in themselves, but when we compare the contents. And they're immutable. That means that they can't be changed in ways. So when you create a string, it's created. And you say, but I saw you doing that the other day, or I saw some of the examples where you're changing things. I did, but there's something called a garbage collector in C# that looks at when strings change or something, harvests them and frees up memory. So there's a lot going on under the hood. Did you do any of that stuff when you did Java? Did you learn about garbage collection and all that stuff? No? No? Are you doing compilers now? Okay, you'll come across all that stuff now. It's great. It's great stuff, okay? Okay, because there's a lot going on when you write programs and you create variables and then free them up again. What happens to them? Do you ever think about that? You need to start thinking about that. Your computer science students in third year, okay? So, so do this at some point. Okay, so strings are immutable. Okay, you can't change after they've been created. So, for example, what's happening when I look at this piece here? I say string B is assigned the value of hello, and then B, we use this incremental concatenation operator. In other words, B is equal to B plus world. What's the value of B? Okay. Do we know? Hazard a guess? Hello world, yeah? Okay. It will be hello world. But how does that square when we say strings are immutable? What's happening is that the software, the program, has created this hello string in memory. And then it points the value of B to that string. Yeah? Then it creates a new string called space world, exclamation mark, in memory. And then it does some work to combine yet another string that it creates in memory, and then it points the value of B to that string. So what happens to the original string hello and the original string space world? They're actually still in memory somewhere. They haven't changed because strings are immutable. And it's the job of the C# compiler as it's running, the garbage collector in there to say, no one is pointing to this anymore. We can just dispose of it and free up memory and reuse this. Okay? Remember this, because you'll come across this in your compiler's course. Help you a little bit about what's actually happening when people talk about garbage collection. It's garbage. The reason it's garbage is because we don't need it anymore. We can't use it. Yeah? So this is what's happening here. So I guess what because I said to you at the start of this class, where I was saying, you're mature or students at this stage, that when you look at the elements of a language and we write something in the language, you have to really think about what's going on now. Okay? There's a lot going on. Now you will, and I expect you to think about this all the time. I don't want you to sort of engage in extensive navel gazing here, about like one line of code. But at some point, you have to just for a couple of milliseconds think about what's actually happening, get it, and then move on. But do really understand what you're doing, okay? And that will really help you and become this kind of mature coder. You could be asked this in an interview question, a coding interview question, what's going on here? Or give me an example of immutability in C#, right? There's an example for you. So this is why this stuff is important, and this is what makes you different from you when it goes to a coding interview. Okay? Do you actually know what's happening? Yeah? So it's really important we do this. Okay? I'm not going to labor this. I'm going to go on now. Okay? But if you have any questions, of course, as I said, you can stop me. So let's have a look at the code here. Here's the string types. I created a string called hello, called A, and a string called B, H, and then I appended this. So now A and B have the string hello. So the value comparison, we use this symbol, the double equal to check, and that checks the values if A is equal to B. But if we want to actually say are they the same objects, then because they're reference type, we actually do this. We call the object class, and we have a class method associated with the object class, and I'm sure you all know what I mean by a class method at this stage. It means that we don't have to have an object instantiated in order to be able to call that method, yeah? We all know this, yeah? Good. So we use this method reference equals A, comma B. Again, you'll notice the reference equals up two words, combining a function here or a method, and then we're using the uppercase, the notation, the convention that's been used in order to be able to use C#, yeah? So this is important that we see this. So we can run this and just see that actually, even though A and B are the same, we I keep doing this. I should really wear my glasses, don't I? Okay, so you could see, hopefully, that the values are the same, but the references are different. And this is important as well. So we want to compare two objects, any reference type. It's important that we're actually checking reference checks. Are two objects pointing to the same piece of information and so forth, yeah? Okay, so we can do this kind of manipulation. And this follows on from C# being, some kind of successor to C, where we still have this connection with being able to deal with references and pointers and all that kind of stuff. Okay, so it's important you have a sense of this. There are other reference types that you're going to come across. One called, for example, dynamic, and one called delegate. And as we work through the module, but you could really have a look at these yourself, the reference type. And if you click on any of these yellow arrows on my slides, it'll take you directly to the link. Okay, it should be there, so you can have a look at those. Okay. We also have something called verbatim string literals, and they begin with an ampersand, no, with an at, sorry, and they're enclosed with double quotation marks. So at hello world. Okay, and the advantage of that is it allows you to be able to escape sequences or not processed. It makes it easy to write. So for example, fully qualified name, here's a fully qualified name. We can just do this at, see, and we can deal with all these backspaces, because if you use backspaces, we often use /n, \n for a new line, \t for a tab and so forth. We can embed these in strings so that they're interpreted, and we don't want to do that. So if that was the case, we'd have to put a double slash in, backslash, backslash, all this kind of stuff. So we don't want to do that a lot of the time. It might be easier to do it like this. Or, you could say, "Ooh, cried the thief," and you can spot the D&D players here. But it's that makes life a whole lot easier for you when you're trying to deal and manipulate and work with strings. Okay, so we can do this when we're dealing with literals. Okay, you can also use the double bracket operator to access individual characters of a string. So that should give you a sense that, well, if it's a reference type, but this is a special implementation of this. It's not an array, but you can make it look like an array. Okay, and so it's important that you understand that how those kind of things work as well. Okay, any questions so far? All I'm trying to do is have you unlearn some of the stuff that you've learned already, okay? And look at some of the C# way. Okay, question in the back there? Yes, it's exactly. So the question, and I'm repeating just so we have it recorded, is that at the bottom of the bottom here where we have this bracket operator here, is that the charat method, class method associated with the string class that we could do? Yes, that's exactly what it is. Okay. So it makes readability a little bit easier for you. Okay. So even so strings are a pain everywhere. Okay, in all of these languages. Okay, because we work with language and we work with strings, so it's really problematic. Okay. Okay, so we have some conditions and decision making, and we know that all of your normal stuff applies. You have if else, you have switch statements, you have the hook operator. That's my favorite expression for decision making. You'll notice from the JavaScript that I use this all the time, everywhere. I do conditions with variables within strings so I can make decisions. It's a pain, right, to read. Okay, it's generally considered to be really bad software engineering. Okay, bad design. Okay, but I love it. So I'm just, and I like doing bad things sometimes. I'm just for fun. So but sometimes if you go to work in an organization, they'll have coding standards, and they'll tell you not to do this. Okay, they'll say you should not code like this because it's hard to read, because the code may be passed on to somebody else. There used to be the Perl programming language. Did you ever hear this Perl programming language? Yeah, so Perl is my favorite language of all time. And I spend a lot of time writing Perl, hacking with Perl, all that kind of stuff, and hacking Perl itself. But every year there used to be a magazine called the Perl Journal, and so there were so many people involved in this stuff. And then every year they had a contest where they'd give you something to write, a piece of code to do something, and your job as the coder was to make it impossible to figure out how the source code should be unreadable as possible. So it was called the obfuscated Perl contest. So it should not be possible to be able to look at the code and figure out what it does. You'd have to run it. The only way to figure it out, unless you were really, really knowledgeable. But so I used to write code that would write code. The code would write code, and it would write code in memory, so you couldn't actually see the code, and then it would change the code and obfuscate the code it wrote, and then run itself. So as the program was running, it would completely change itself and morph. And yeah, I only ever managed to come second in the world in that contest, but I wasn't the best, but it was I was old school, real old school stuff. But anyway, don't do what I do, okay? Not good as software engineers, and I'm not a software engineer. I'm a coder. So, but you're software engineers, most of you. Some of you are multimedia and web developers, but you need to do some software engineering as well. So anyway, we look at hook. As I said, if I was you, I wouldn't do that, and I don't know what's after happening there, but we'll see. We've lost the display. Hopefully we can capture it. Come on, machine. Okay, you seem to have lost our display. I don't know what happened. It just seems to have failed here. I'll turn it off and turn it on again. Usual computer science approach. Ah, we're back. Okay. I don't know why it's telling me there's no display. Sorry about this, guys. Hmm. Ah, we're back. Sorry about that. I don't know why we didn't get that. Okay. Okay. It just seemed to fail. Okay, so we'll quickly move on then. C# provides a switch statement, um, which is always useful. It also allows you to be able to have enumerations. Did you work with enumerations in Java? Yeah, we saw some of. We pretended to have enumerations when we were working with some of the JavaScript at some point. So we can have a look up here, and you can see that we can create something called an enumeration. That's some kind of ordered set. You know your maths. Remember you did sets and maths. So we have members of the set. So here we have a set essentially called colors. It's a set of colors, red, green, and blue. And we know that red is the first. It has an order. It's ordering 0, if you like. Then green would be order 1, and blue would be order 2. And we know that, for example, green would be greater than red, and blue would be greater than green. Right? Yeah. So it's a set of these items here. So we are able then to be able to generate a random number then between. We can create a color, which is this type, okay, that we've created, color. This is an enumeration. Create this color called C. We're boxing or boxing. We're casting here, yeah, and so forth. Yes, sorry. Yes, it starts from 0. Oh, we'll always count from 0. Yeah, it's good to know. I forgot that myself. Okay, as well. Well, because when I did if you look, you'll see that there's a loop here, and I was generating a number from 1. I did from 1 to 1 to 2. So I made that mistake myself. So that's why I'm pointing it out. Good question. So we're generating a random number here, be sometime between greater than 0 and less than 3, and then we're able then to check the value. Okay, so if it's 0, essentially it's red, green, or sorry, this is between 0 and 3. If it's a number greater than 3. Sorry, this will give us a random number between 0 and 3. Okay, but we know that it's 0, 1, 2 here. Okay, because we've only got 4 elements in the color set. So that sometimes we might get the number 3 generated. So that means we don't actually know the color. Okay? And we're just using the switch, checking the different cases. Okay, so the example here is to make some semantic error, some mistake here. Okay, so that's why we have this default position here at the bottom, so that we sometimes make semantic errors, and sometimes we might want to catch our semantic errors. Another question, sorry. Yeah. this function, yeah, this random number, it's really important you have a look at the question is relates to but the exclusivity of the numbers here and the random number generation around this. So this is much, it's done a lot of the work for you. Okay, so if you look at the random class, and I think I have a link to the random class, actually I have a link to the random class here, okay, you can click through and see that these functions that it provides you, like next, will provide you with information on how to do this. Okay, it's nice, much nicer, more intuitive, easier to use. Okay. Again, iteration, we have the usual looping. We have while condition loops through a block of code. The do condition tests, do while, it contests after. So you know you have a pre-test, a post-test, and then you iterate for a fixed number of initializer conditions, iterators. And then we have the for each or for operators as well. You know, so there's lots of these, and you can find these too. I'll give you a little example of using for, because I want to give you this example because it relates to your assignment, just somewhat. We'll switch to code. So what was it called? It was called my loop here. Okay, I'm going to okay, so this is my loop, and let's have a look at this piece of code. Okay, so this piece of code sets up and uses that random number generator, the question like you asked earlier, and you were asking about some of these things also. What's important, I guess, is that when you want to work with random numbers, you create a new random object using the random class, and then you can use that to generate random numbers for you. Okay, and there's lots of ways that you can do this. Okay, it's seeds as a generator, so it's nice to be able to do this. So really what I wanted to do in this particular example was to show you how to write using iteration and a nested loops to generate tables, because your assignments are based around essentially generating tables from some data structure, yeah? So it's not too bad. So here's how we generate a table using the HTML table command, using randomly generated set or number of rows and a fixed number of columns, which is also randomly generated. Okay. It also pulls together some of the things that we saw earlier. So here we have a random number generator called RND. Here we have using that to generate a random number of rows and a random number of columns. Then we're iterating over the rows using our much loved for loop that you did on probably the first couple of weeks of first year. And I'm writing out a table. So this is what's this string going on here, you know? So really what's happening here is I'm trying to use the value of a variable, the index variable R, embedded in the string. Okay, and I'm using this dollar form of the string in order to be able to do that. Don't mind the commented outline. And then this just gives me all of the same with the columns. Again, I'm using so we generate the table initially. Table / table. TR / TR. And embedded in that R we have TDs, which is our column elements. Yeah, so we know all this from our web dev. Yeah, so I'll run this, and that's the end of the program. Okay, we have a little function there that I've created, class method, but let's have a look at the terminal. So let's open the terminal. And we've generated this random table that just has 2 rows and each have a column. Okay, so you're going to have to do this kind of stuff with Markdown or something, JSON or something earlier. So it's as simple as that to generate. Okay, so it's not hard to do this, and and really the whole purpose of this particular assignment is to get you doing all the various basic stuff. Okay, if you're rusty, it will be a bit difficult. Okay, I mean, I'm not saying it's going to be easy for everybody, but you can look at this. But what I also wanted to show you a little bit in this particular example is how we might work with tabs. I don't like these tabs. I use tabs to generate the table, tab in, 8 spaces. I much prefer to tab in 4 spaces or 2 spaces or whatever, because sometimes it goes all over, hard for me to read. So I thought, what I'll do is I'll write a little padding function that would allow me to do this. Okay. So instead of the tab and using this /t here to tabs, I would actually replace it with a space. I write my own function called pad space, and I could decide the number of spaces I wanted to have. Yeah. So I created this function because, you know, a public static string pad space. You'll notice that I used a capital P, capital S, those rules that I talked about earlier, because I'm making my own functions and methods here. So I want to be able to do it the C# way, yeah? So this so it doesn't matter. Look, you can call it bananas, lads. It doesn't matter what it is, okay? It will still work, and you'll still get the marks if it works, right? Just try to embrace doing things C# way, please. Okay. So all this does then is it uses the pad left function to add some spaces to a string. It's a bit of a hack. I know it works this way, so I'm able to get 4 spaces this way, or 5 spaces, or C spaces, and I can call that. And then instead of this line with the tabs, I just comment out this one, use this one, and you'll see that we'll save this, run it again. And you'll see this time I actually had my 4 spaces for the indentations around about here. I'm still using the tabs elsewhere, but you could take this piece of code and modify it yourself and use it, okay? Any code I give in class, any code I give in my demos, you can reuse that code in your assignments, okay? Anything that's on the Microsoft documents, you can reuse. Just note that you're using it, okay, in your assignment. It's not cheating to do this, okay? Not cheating to give back any of the stuff that I have modified, all right? So people often ask me this, and it isn't a problem, okay? Please feel free to use this. We missed a couple of minutes there, so I've just got just a little bit quickly to the last few. There's an example here using for each, and it allows you to iterate through a collection, and you'll see here it's possible to do, I use an example where I created a linked list, okay? We'll come to that a little bit later, okay? It's there if you want to have a look at it. It's not crucial at this stage. You don't need to do it for your first assignments or anything, okay? It's grand. And again, I also have a little example and a demo in the files where you can, if you wanted to move ahead, because some of you know how to code this stuff already, you could have a look at how you might want to build classes and objects in C#. We'll do that next time, but if you wanted to prep for it, maybe run this little demo on Shapes demo in the actual code, and it will help you. You know, again, these are not good designs, and I must say we're looking at coding here, learning the elements. We might need better designs later. Okay. Thank you very much for your patience. It's good to see you all, and I hope the labs and tutorial go well for you. Okay, thank you. Bye-bye.